Simplifying rational expressions. Let's first just remember what a rational expression is. A rational expression is a fraction with some letters in it. In this section, we're going to look at reducing, multiplying, and dividing. So I put up some problems that are very simple with arithmetic. For our first one, it is just to reduce because there's only one fraction there. Remember, we do this with exponent rules. So you have numbers, you have x's, you have y's. For the numbers, do plain old reduce. You have a common factor of 4. 4 will go into 4 one time, 4 into 12 will go 3 times. If you have a hard time reducing, learn to reduce on your calculator so that you get lowest terms. So we have 1 over 3. For the x's, remember to subtract exponents. So 3 minus 1 will leave us 2x's, or x squared. We only have one y, so we're going to keep that y. And since there is something else in the numerator, you would not need to write the 1. So you could just write it as x squared over 3y. Our next problem is a multiplication. So you want to watch on all of these. Do you have one fraction? If you have 2, is it multiplication or is it division? So for this one, multiplication, remember this is where you can simplify first on the diagonals. So if there's any common factor, divide it out. So we can divide by 2 on this diagonal. 2 goes into 2 one time. 2 goes into 8 4 times. On the other diagonal, 3 will go into 3 one time. 3 into 9 will go 3 times. Then we multiply across numerators and denominators. 1 times 3 is 3. 1 times 4 is 4. It's already reduced, so you're good. The next one, we have a division. Remember, for division, you have to change it to multiplication and invert the divisor, or you may have been taught multiply by the reciprocal. You cannot cancel when it's in division. You have to change it first. They're trying to set you up. They want you to take out that 2 or take out that 3, but you're not allowed. So we're going to keep the first fraction. We're going to change to multiplication, and our divisor is going to flip over. Now when we check our diagonals for canceling, there is nothing. 3 times 3 is 9, and 4 times 2 is 8. There are no common factors. We'll just leave it there. We don't want to go to a mixed number. We would rather have one piece. For the first couple of problems, they started us off with things that have monomials. Monomials, remember, have no signs in between. They're already a multiplication. With this, you go ahead and just simplify on the diagonals, just like regular simple fractions. So we can, on this diagonal, we can divide by 2. 2 goes into 2 one time, 2 goes into 8 4 times. On the other diagonal, 3 and 5, there's nothing. With this many variables, I probably would not cancel as we go. I would just clean it up in the answer. So let's go across for the numbers. 1 times 3 is 3. For my variables, I have a squared, b, and c squared. On the denominator, I have 5 times 4 is 20. I'm going to put these in alphabetical order so they'll be easy to see. A cubed, b squared, and c. So now we're going to reduce. Nothing we can do with the numbers. On your variables, remember you subtract the exponents. If you have only positive exponents, you can do biggest minus smallest. Remember, it will stay wherever the largest exponent is. So I'm going to keep my 3 over 20. For my a's, I'm going to have 2 a's left in the denominator. For my b's, I have b squared and b. They will stay where I have the most. So I'll have 1b left in the denominator. And the c's, 2 minus 1 will leave 1. This time my larger exponent was on the numerator, so it will stay on the numerator. Our next problem also has monomials. It is a division problem, so we're going to have to change it to multiplication and invert the divisor before we do anything else. So I'm going to keep the first fraction. I'm going to change to multiplication and I'm going to flip the second fraction over. Right, now we'll try to cancel on the diagonals if there's common factors. You can cancel with the 2 and 4. Divide by 2. 2 will go into 2 one time. 2 will go into 4 two times. On the other diagonal, you have a common factor of 3. 3 will go into 6 two times. 3 into 9 will go 3 times. Right, and I will again just reduce my variables at the end. So on my numerator for my numbers, I have 2 times 2 is 4. I have 2 A's, 5 C's, 6 X's, and 2 Y's. Right, on the denominator, 3 times 1 is 3. I'm going to keep these in alphabetical order so they'll match up nice. So I'm going to put A, C will go next, X, and Y. And now I will simplify this fraction. There's nothing to do with the numbers. We'd rather have just one fraction. So we're going to keep the 4 over 3. For the A's, remember we're going to subtract exponents. 2 minus 1 will leave us a to the first on the numerator. For the C's, if you do biggest minus smallest, 7 minus 5 will leave us 2 C's on the denominator. The X's, 6 minus 1 will leave us 5 X's on the numerator. And the Y's, 2 minus 1 will leave us 1 Y on the numerator. As we get into the problems that are the main focus of this section, you will notice that we do not have monomials in the numerators and denominators. And there's a very important thing that you need to do, because in order to cross things off, you have to have products. So to get products there, we are going to factor first. Is this rule important? Yes. Right. So before I can do any reducing, I have to try to factor. Now, with exponents of only 1, the only type of factoring I can do is a GCF. So I can take out a 9, and that leaves x minus 4. On the denominator, I can take out an 8 as a GCF, and that leaves x minus 4. Once you have products, then you're allowed to cancel or divide out. So we're going to divide out our x minus 4, and our final answer is 9 over 8. But make sure that you factor before you try to divide anything out. Our next problem is also a problem just to reduce, because it is only one fraction. It is not monomials. There are signs in between, so we have to factor before we can cross anything off. Our numerator is a trinomial, so remember that goes into 2 sets of parentheses. That's like your backwards FOIL. Right? Do your signs, different signs. Split the x's. We're multiplying to get 9 and subtracting to get 8. So 9 and 1 is going to work. And we want a positive 8, so 9 should go with the plus. Bigger number with that sign. Right. Double check. You want to do it on the side or in your head, so it's not in the middle of your problem. But that does give us 8x. For the denominator, we have to think about it, but your exponent is 1. That means your only choice for factoring is a GCF. There is no GCF, so it's already as low as it can go. That's an important thing to be able to decide. So it's the exponent. That's the clue. Right, now we're allowed to divide out anything that matches. The x minus 1 will divide out, and so our answer is x plus 9. You will soon notice in these problems that the real work is just factoring. So we have to factor everything before we can divide out. And our numerator is one of the trinomials with a number in the front, so it's going to be a lot of work. I'm just going to kind of get it started and give you the answer. I'm going to have different signs in there. For 3, I would have to use 3 and 1. And for 8, I can try 1 times 8, 2 times 4, 4 times 2, or 8 times 1. So I would have 4 possibilities there. The choice that works is 2 and 4. Let's double check just in our head. Here's minus 12x plus 2x. That gives you minus 10x. Right. Denominator is a trinomial, but it doesn't have a number in front, so it's an easier one. Like signs both minus. Split your x's. And for 4, 4 and 1 is going to work to give us 5. So once everything is factored, then you can try to cancel or divide out. So the x minus 4 divides out. We are left with 3x plus 2 over x minus 1. You can't take anything else out. Our next problem, we also see that the factoring is going to be the work. On the numerator, it is a trial and error problem. We will do the parentheses, different signs. We're going to use 3 and 1. And over here it is 1 and 2 or 2 and 1. And it is 1 and 2 that works. So minus 6 plus 1 gives us minus 5. So we're good there. Our denominator is 4 terms. Remember, that is grouping. I'll go ahead and work through that just to remind you. So grouping, we split up. And in the first group, we look for a GCF. So we can take out a 3 and an x squared. That leaves us 3x plus 1. If you take everything out, you have to put the 1. This one already matches our second group. Notice there is no GCF there. So if we want it to look like our normal problems, we could always write a 1 outside. And you don't have to do that. Right. This is our GCF. And to get back to the line above, we have 3x squared plus 1. And that will not factor anymore. So we have 3x plus 1, 3x squared plus 1. And now we can actually get down to our reducing. The 3x plus 1 divides out. So we are left with x minus 2 over 3x squared plus 1. Our next problem is a multiplication. We also have to factor this before we can do any work. So our first numerator is a trinomial. We can put our parentheses. It is going to have different signs. Split the x's. We're multiplying to get 8, combining to get 2. How about 4 times 2? And we want positive 2, so we need the plus with the 4. So minus 2 plus 4 gives plus 2. We're good there. Right, denominator, also a trinomial. Like signs both plus. Split your x's. And how about 3 times 1? Multiplies to give 3, combines to give 4. On the second fraction, on the numerator, because your exponent's 1, your only choice is GCF. We can take out a 3. That leaves us x plus 1. For your denominator in that fraction, the exponent is 1. Your only choice is GCF. There is no GCF, so there is nothing to do. Right. Now we're ready to simplify. You do want to cancel in these problems. Right, so we can do our diagonals, and you could also do straight up and down if there's something. So we have on this diagonal an x minus 2. On this diagonal, we can do the x plus 1. And that looks like everything. So I'm going to go below just because I'm going to run out of screen room there. On my numerator, I have a 3 and an x plus 4. Normally, you will see them write the monomials first. Denominator is x plus 3. You can leave the answer here. There is no reason to multiply out that numerator. Just leave it here. It shows that it's already reduced. Our next problem, also a multiplication. We have to factor before we can cross anything off. This one has a lot of detailed factoring in it. I'm going to do the 2x cubed minus 16 on the side, and then I'll just erase First of all, it has a GCF. It's not cubes right now. You can take out a 2 though, and that leaves you x cubed minus 8. This one is a difference of cubes. All right, so we're going to keep our 2. And remember, you take your cube roots. So we're going to do an x and a 2. So our first parentheses will use the sign of the problem. Second set is a trinomial. For our signs, the first sign is the opposite, last sign is always plus. And then all the combinations of your roots. So first times itself will give us x squared. First times second will give us 2x. And the last one times itself will give us 4. So that all goes in the first line. So 2 times x minus 2, x squared plus 2x plus 4. And remember that trinomial will not break on down when it comes out of a cube. Right. Now I'll work on this denominator. And I'm also going to do it over here and then erase. First of all, it has a GCF in there. I can take out that 6. And that leaves x squared plus 2x and 6 into 8. 6 into 48, sorry, we'll go minus 8. This trinomial, we have to see if it will do more. And so we can use 4 and 2. Multiplication. This numerator, a little easier to factor, just has a GCF. So take out a 9, and that leaves x plus 6. This denominator, I'm going to go down below. First of all, it's going to have a GCF. It has a 3 in there. So we have a 3, and it's leaving us x squared plus 2x plus 4. If we try to keep factoring this, which we should, our choice is 4 and 1 or 2 and 2. 4 and 1 would add to give us 5, and 2 and 2 would add to give us 4. So we're not going to be able to get the middle. So this will not break on down, but we thought about it. Now we're ready to simplify on our diagonals. And what we notice is that this big trinomial actually cancels with this one. Let's see, my x minus 2 I can cancel vertically. X plus 4 and x plus 6, you can't do anything there. We can reduce these fractions if we want, or reduce them at the end. It doesn't matter. 2 will go into 2 one time, 2 into 6 will go 3. I can also go on this diagonal, or I could go vertically. 3 will go into 3 one time, 3 will go into 9 3 times, and my 3's here will actually cancel. So let's see what I do have left. I have nothing in this numerator, so just a 1 times x plus 6. So I have an x plus 6 left. On the denominators, all I have left is x plus 4. Make sure you stop here. You have signs between. You're not allowed to cross off the x, or you're not allowed to do anything over here. So this is our answer. Our next problem, notice, is a division problem. So we're going to change it to multiplication and invert the divisor. We have to do that before any canceling. So because this is just so much writing, I am going to factor and flip at the same time. All right, so on my first numerator, there actually is no factoring you can do because the exponent is 1 and there's no GCF. The denominator on that is a monomial. It's already a product, so nothing to do. All right, I'm changing to multiplication, and this one is flipping. So the 3x to the 4th y goes to the numerator. It is a monomial. It is already a product, so nothing to do. This one will go to the denominator. It is a difference of squares. So x plus y, x minus. And now we're ready to start simplifying on our diagonals. So the x plus y we can take out here. You can take out an x off of here and a y, or you can take them off over in your answer. It's up to you. We'll just carry them over and take them off over there. So we have a 3. We have x to the 4th y on the numerator. We have xy, and we have x minus y. And so we can simplify this x's and y's. We'll keep the 3. The exponents subtract, leaves us x cubed. The y's will actually cancel. The x minus y is left in the denominator. We'll look at one more problem. This one is a multiplication, so we don't have to flip. We're going to factor everything. Numerator on the first fraction, all we can do is a GCF. So we'll take out our 18. That will leave x plus 1. Denominator, we can take out a 12. It is also GCF. It leaves x plus 2. Multiplication here. Numerator, we can take out a 3. GCF, that leaves x plus 2. And that last piece to factor, it's going to be 2 steps. I'll do it down here. We can take out the 6 as a GCF. It leaves x squared minus 1. And x squared minus 1 is a difference of squares. So x plus 1, x minus 1. Right. And now we're ready to simplify on our diagonals. So we can take out the x plus 2. We can take out an x plus 1. If we want to go this way, we can divide by 6. 6 will go into 18 3 times. If we want to go this way, we can divide by 3. 3 will go into 3 1 time. 3 into 12 will go 4. And that looks like all we can do. So now we'll put it back together. So going across the numerators, we have 1 times 3 is 3. Across the denominators, we have a 4 and an x minus 1.